In this lesson, we're going to take a look at AP Calculus topic 2.10. Now that we know the quotient rule, this form is written in prime notation, as well as the derivatives of the sine and cosine functions, written here in Leibniz notation. We can find the derivatives of the four remaining trigonometric functions. That's because we can write them as quotients that contain sine and cosine. Tangent can be written as sine divided by cosine. Cotangent is cosine over sine. And secant is 1 over cosine, and cosecant is 1 over sine. Let's consider tangent, which we can write as sine over cos. To find the derivative, we can apply the quotient rule. Low, d high, the derivative of sine is cosine, minus high, d low, the derivative of cosine is negative sine. And all of that goes over the function on the bottom squared, which we can simplify to cosine squared x plus sine squared of x, all over cosine squared of x. And since sine squared plus cosine squared equals 1 by the Pythagorean identity, the numerator becomes 1. We have 1 over cosine squared x, which is the same as secant squared x. So the derivative of tangent of x is secant squared of x. We can do the same thing for cotangent. Rewrite as cosine over sine. Apply the quotient rule. We can rewrite use the Pythagorean identity, use the reciprocal identity. The derivative of cotangent of x is negative cosecant squared of x. Try the next one on your own. Secant can be written as 1 over cos. Apply the quotient rule. Low, d high, the derivative of a constant is 0, minus high, d low, the derivative of cos is negative sine, all over the bottom function squared. This here is gone, and minus a negative is positive. We can split the denominator and rewrite as two fractions. 1 over cos is secant, and sine over cos is tangent. So the derivative with respect to x of secant of x is equal to secant of x times tangent of x. You can do the same thing for cosecant and get the following. You'll want to memorize these. To help you remember the ones with negative derivatives, they're the trig functions that start with co. Cosine, cotangent, cosecant. The most important ones to remember are sine and cosine because you can use them to derive the others. But you'll end up wasting a lot of time on your exam if you don't memorize them beforehand. At the end of the course, I'll put all the formulas you should memorize for your exam on one sheet. Let's do an example. Find the derivative of this function. The derivative of x is 1, minus the derivative of tangent x, which is secant squared of x. Let's do one more. Find the derivative of this function. You'll need to use the product rule. To apply the product rule, we write the first function times the derivative of the second function plus the second function times the derivative of the first function. And after factoring out secant of x, we get Because of trig identities, the derivatives of trigonometric functions can take many forms. This is sometimes a challenge when you're trying to match your answer to one of the choices. So if your answer doesn't match one of the choices, you might just need to simplify more. And oftentimes simplifying requires more work than differentiating. You should note two characteristics of simplified forms: the absence of negative exponents and the combining of like terms, which often involve using trig identities. Let's practice that with one more example. In this problem, we're asked to differentiate both forms of the function, and we'll see that a derivative can be expressed in multiple equivalent forms. So we'll get some practice simplifying. Let's work on the derivative of the first form. Go ahead, apply the quotient rule, see what you get. The derivative of 1 minus cosine of x is 0 minus negative sine of x. Minus a negative is positive, so that simplifies to sine of x. The derivative of sine of x is cosine of x. This simplifies to sine squared of x minus cosine of x minus cosine squared of x, all divided by sine squared of x. From our trig identities, sine squared plus cosine squared is 1. So the numerator becomes 1 minus cosine of x. So there's the derivative of the first form. Now work on the derivative of the second form. The derivative of cosecant of x is negative cosecant of x times cotangent of x. And the derivative of cotangent of x is negative cosecant squared of x. To show that these two derivatives are equal, we can take the first form and split the denominator. And rewrite cosine of x over sine squared of x as one over sine squared of x is cosecant squared of x. And for the second term, 1 over sine is cosecant times cos over sine is cotangent.